Okay guys, as promised, this video is just for all subscribers and not for public. So in this video we will see how to obtain to draw the tail, which we use this formula where r is the dimension, the radius of the former, radius not diameter. d1 is the distance between two formers. Alpha is the angle of the overall airplane. So as I told you, in this case is 12 degrees, but you can choose your own. I mean, there is not a rule, a strict rule. I saw that depends on the lift coefficient, but you can do what you wanted. This just for your imagination. Okay, I prepare this Excel file, which is not a formula, because in Excel the tangent formula is for radian and we are using degrees. So the first former is 100, the second former using this formula is this value, and so on. As I told you in the previous video, we have that for the former one is 100, which we put in our formula and gives 89.37. so the 2 is 89.37. if we put this value in our formula, gives the third radius, which is 78.44. If we substitute this value here, gives 57.48. Okay, so this is the radius of our 7 formers. This value distance is the distance between the middle point of the radius of the former one and the center of the following former, let's say former 2. So this is 0, this is our mid plane. This distance is this one, which is 0.628 for the former 2. For the former 3, these are all aligned. For the former 3, we have this distance, which is is 10.728, but referred to the center line is multiplied by 2, and so multiplied by 2, by 3, by 4, by 5, by 6. In the end of all, you will have all these values, and then we will put here. Okay, so let's see in detail. Plane 1. The distance between plane 1 and reference plane is 100 millimeters. The distance between the center of this circle and the center of the overall drawing is 0.2, but if you see here this value. Okay, this curve changes. The last one, the distance is 763.768. So cool. Doing this, all the circles are aligned, but this is the last step you have to do. The last, remember, the last. The first one I will show you. Okay, so we add a sketch. Radius 100. Perfect. Then you add a reference geometry. Front plane, flip direction, 100, 2, 3, 4, 5, 6. Perfect. Okay. If you use the technique that made all the tail in a single part, you can have the reference of the previous circle. So the second former is 89.37. So we come here, plane 1, radius 89.37. I will make just 2 because this is too long. 78.744. So plane 2, 17.744. Okay. Now we have to build all the slots, all these slots. Now you will see how align all the formers is the last step, because since we will draw our slot. First of all, this one. Second, this. Then infinite length. Okay. No. this at 30 degrees, and then we will build another one for construction at 45 degrees. Okay, so let's go back. So we have draw our circle with 3 vertical lines and separated by 5 millimeters each. So the next step is to draw a horizontal line, but since we don't have our reference point here, we trim. And now we have our distance. We erase our smart dimension and transform for construction line in construction line. Okay, so once you have this, we use circular pattern. We have to indicate this, the direction, and then here in these two patterns we choose this. We have 4 equally spaced on 360 degrees. As you can see, they are painted with yellow. Boom. Accept. And we have this part. For our slot for stringer is the same. We build two lines which are parallel. Oops. No. This is not what we need. Okay, I don't remember how. Yeah. No, sorry. I don't remember how I did it. Okay. Yeah, I remember. Vertical. This happens because we have to delete some relations. Oh. Now we will try another technique. Okay, then we trim here. This is 2.5. These are 2.5. Then we fine, trim. Okay, so once you have one of these, you choose the direction, entities to pattern, and then we have 12. Or what else? Then you accept and boom. Yeah. Sorry, this is the correct. We choose the verse, the direction. Entities to pattern. Instance to skip. We will skip this instance, this, and this. Then you trim. Yeah, this happens because these are all the lines. Okay, so this is the first one. Don't try to scale this drawing in sketch 3 or sketch 2 because you will scale also this dimension, and you have to maintain the same dimension from the first to the last former. So this is our first former, and the other one are made in the same way. Okay, welcome back, and now we see the second stringer and why you have to align all the parts and at the end we see that this part, this sketch is aligned with the bulkhead. So let's see what happened. Okay, I draw the three lines, and now I will build the horizontal one, then trim this. We erase the smart dimension, cancel, cancel and cancel. We transform our entities and okay. And now we use the circular pattern. Okay, first you see that all the slots, the line are not aligned. We can move the part upwards in order to make this the center of rotation of the circular pattern which coincide with the center of our circle, but these 2 millimeters can play a very drastic role because we will accept and now we will trim. You see what happened? This is because there is a 2 millimeters, not 2 millimeters, 0.2 millimeters that are missing. So this means that you have to redraw, and this is not a good. This is not good. So this is why you have to align all the sketches in the end, because if you repeat the process at the end, in this case, the center is aligned, the center of the drawing is aligned with the center of the sketch is aligned with the center of the drawing. So you trim it, trim here, smart dimension from this to this. No. Cancel and cancel. You see that you are reducing the radius, so this is a big mess. We indicate the direction. The center of rotation is the center of the sketch and of the drawing. Then we choose the entities to pattern, and boom, it's done. Of course, this is one and two, and now this is the last one, I think. So the last one should be sketched here, and should be 63.768. Move entity. .728. 68. No, it's not the last one. Maybe the fifth. Okay, go to 5th. Now we exit the sketch, we extrude, we extrude, and we extrude. Change material, and voila. You have your tail perfectly aligned. It is a good practice to check. You see this difference is because we are rounding this value. The real value is not 10.63, but is the same. So the difference between the rounded number and the real number leads to an error in with this alignment. So how to overcome with this? Well, this is easy. You come here, edit sketch. You will show the first one, and then you will add I think I made a mistake, but it's not a problem. So the problem is with the other one. Okay. Sorry. Let me see. God. Yeah. Okay. So you have to make some post-production. But it's okay. Okay, so this was the first part, and For the fuselage, for the cylindrical part, we will make something like this. No, sorry. We'll show this and we will hide this. So let's say that this is our former for fuselage. 800. Easy. Yeah. This part. And if you multiply this by 10 and then you add your sketch 1 2 3 4 okay, you have your fuselage. Okay, it's done. Show. Here you have your fuselage and the tail. We can improve our response to loads or increase the strength of the model just by drawing one line here, one line here. We set up 10 10, we trim, we edit our feature and then okay, you have your former reinforced. This is